So this is the outline of the presentation. If we first try to understand what is the power flow in AC system. In fact, I had discussed this in previous class also. I have a slight review on that. Then what is the flexible AC transmission system? What are the problems with the present power flow? And what solutions a flexible AC transmission system can provide? What are the devices, the static valves? Then one of the such devices is static valve compensators. In fact, we have discussed this static valve compensators in the last lecture on the reactive power management. So we will have slight duplication on that, but we will skip those slides and we will discuss in detail what is its applications. Okay, we had not discussed about the characteristics, etc. So that we will discuss today. Then another device is StatCom, substitute of SBC. So we will discuss on that. Then static series compensators. These are two devices. Thyristor controlled series capacitor series system and triple SC, that is a synchronous series capacitors. Then unified power flow controllers, UPFC. You've heard the name of this?
I already studied this subject in self-study. For self-study, I also
self-study.
भूल गया हूँ लेकिन किया था जब बीटेक पढ़ रहा था.
अच्छा, during the BTech itself. Okay. And the applications of fax devices where they get used. Okay. So this is the famous equation. Power flow is equal to V, sending end, receiving end voltage divided by X sine of delta. Delta is the angle between two voltages. So when we talk of power flow control, how can we control power flow? You can look into this equation.
Controlling the delta. And
controlling, first thing is the voltages. How much voltage can be controlled? If you increase the voltage, more power will be transferred. But how much thing you can increase? 1.05 is the limit. You cannot go beyond 1. Otherwise, the voltage equipment will get overstressed. So 1.05 and square of that, sending and receiving end, then very little. So there is very limited scope for changing the voltage. Of course, the voltage can be changed by the reactive shunt compensation. Shunt compensation can push the voltage, but it's a very limited scope. You cannot change much. Then second thing is the impedance control. That is inversely proportional to the impedance X. In a transmission line, as such, the transmission line, it consists of towers, conductors. You can calculate the impedance by what is the GFD, etc., GMR and all. But you cannot change that by normal means. Normal means it cannot be changed, it is fixed. So this also, impedance also cannot be changed. Then delta. Delta can be changed, but delta is very complex. You can change the delta at will.
25 to 30.
But at will you can change, but by phase shifting transformers. It's a very complex. You cannot change. So what I mean to say is that AC system as such is very inflexible. The flexibility is not there. Like generator. Generator, you can, let us say it's a 200 megawatt thermal machine. You can change it at your will. You can generate 100 megawatt, 150 megawatt, 160 megawatt anytime by changing the valves. Of course, minimum 50 to 60% load should be there. Then hydro you can change very quickly. Thermal you cannot change very quickly. So there is a inflexibility to that extent. Gas you can change, but transmission line is inflexible. So that is the meaning of inflexibility. That you cannot change at will. You cannot control the power. Why you have to control the power? Today, what is the challenge? There is a demand, continuously increasing the demand, more power, more electricity, more. Even now, the transport sector, which was mainly supplied by the petrol and diesel, they are also shifting back to EVs, electric vehicles. So demand for power is increasing, industrialization is increasing, need for the refrigeration is increasing, heating load is increasing, so more power is required, better quality of the power is required. Young generation totally dependent on power, and they demand a good quality because voltage should be stable, frequency should be stable. Machinery industry, in fact, is sensitive to the frequency, motors, etc., sensitive to the frequency, static devices, so quality of the power. Reliability should be there, and of course, that should be a lower cost, lowest to the cost. What are the issues? Constraints. System is already operating very close to the stability limits. Already loaded. You don't have enough margins. Then, inflexibility of control. You cannot control the power. That we have seen. In present day AC system, inflexibility is there. Safety margins are also less. Lines already loaded. Then difficulties in interconnection, uncertainty of loads. Load can come and go anytime. You have to keep on matching. Then deregulation in open access. This has created another problem.
After 2003.
Even before that it started. Since you have raised this issue, when the CRC came?
CRC sir 2003 का एक रूल था उसका.
2003. आप देखिए गूगल में सर्च करके. CRC was formed in 1998.
मतलब उसका
तो 2003 के एक्ट से मतलब नहीं है. पहले का होगा. In fact, deregulation process started in 90s itself. The act was not there. The act came in 2003. Before this act came, 6 boards, electricity boards, have already unbundled. Odisha was the first to unbundle. Odisha unbundled in 1994 or 95. Haryana has unbundled. Your Delhi was unbundled just before Act or 2002 or 2003. So, in fact, the process of unbundling had started even before the 2003 Act. Under the pressure from, in fact, it was suggested by the World Bank. And 2003 Act came only so that each state doesn't have to unbundle itself. So there is an Act which in fact culminated all these things. So what is the issue there? Because of this unbundling, so many agencies have been created and there is a lack of coordination. Each company is acting in its own self-interest, not in the interest of the grid. So there is a problem with the regulator in the grid. So there is a deregulation and environmental considerations. You cannot lay more lines. You cannot build more power plants.
clearance लगता है, forest clearance लगता है.
So many issues are there. So these are the problems. Under this problem, we have to operate. So, what are the bottlenecks? We have, just to review, steady state power transfer capability, voltage stability limits, transient stability limits, dynamic oscillations, inadvertent loop flows, power flowing in the loops unnecessarily, and thermal limit and short circuit current limit. So many bottlenecks are there in the power transmission. So how can add the flexibility and how it can solve these problems? What is flexible? First, alternating current system which incorporate the electronic based and other static controllers. This is to enhance the controllability, increase the controllability and increase the power transfer limits. That is a flexible AC transmission. So basically, in the conventional AC system of transmission lines and conductors, if you can take help of this electronic based static controllers, then you can make this transmission more flexible, controllable, and increase its power transfer limits. What are these static controllers or devices?
Thyristor.
In fact, initially it started with the thyristors. Thyristor is the it started in 1950s and 1960s.
Hydratron plus transistor.
Thyratron, basically it's a mercury arc rectifier. So that was even before. Before it was there, but it was very difficult, Thyratron. So it was not a static device. If you talk of a static device, then thyristor is a static device. So thyristor based systems started coming. First was the bulk transmission with the HVDC. Back-to-back links came. Static war compensators came. Phase shifting transformers came. Thyristor controlled series compensators came. Then there is a change. Second generation devices came. Thyristor, as you know, once you fire the gate, then gate loses its control. It cannot turn it off. It has to be turned off by
line commutation.
Line commutation only. Then these devices came. It's the second generation devices, GTOs, IGBTs, IGCTs. These devices, in fact, simplified the whole thing. HVDC, the conventional HVDC was very huge. Then with the voltage source converters, VSCs. In fact, HVDC, they started calling it light HVDC because it became light. It doesn't require huge reactive power support. HVDC light, basically the VSC based, it requires filters. Filters are required, but filters are required only for harmonic suppression, not for the reactive power support. Then StatCon came, SSSC came, and UPS. So these devices, in fact, starting from here, HVDC is not considered as a fax device, but of course this is also static controllers and it increases the controllability. The fax devices are basically considered as these. These are known as fax devices. What solution? We are looking for solution of the problems. This facilitates efficient and effective utilization of existing transmission system by controlling the power. If some line is getting overloaded, some line is getting underloaded, so you can transfer the power, which was not possible. Otherwise, the power flows by Kirchhoff's rules. Utilize the development in power electronics for advanced controls. System operation is improved. You can maintain the voltage and frequency much better. Minimum infrastructural investment. You don't have to create more lines, so the cost is reduced. Then minimum environmental impact. Environmental impact will also be minimum if you are using FACTS devices. Then minimum implementation time. See, line construction takes very long time because you have to put the towers everywhere in the field. Whereas these devices are put in the substations, which are small places, small devices, and then the implementation time is also very less. So facts can provide solutions.